students. Today we are here to discuss about the physical methods of the preservation of the food. Now the food is processed which leads to the preservation process where we increase the shelf life of the food so that it could be consumed safely by the human race. This processing of the food can be in batches or it can take place in continuous pattern. Now both the conditions, whether it's a batch processing or a continuous processing, has got advantages as well as disadvantages. The advantages of the batch processing is it has got a greater flexibility to change the product formulation and the rates, the lower equipment cost and the easier operation and the control. So these are the advantages that we come across in the batch processing. However, in the continuous processing method, we found the advantages are as follows. We have lower operation and labor cost, there is less floor space required and a great product uniformity because all the products are going in a continuous pattern. Now whatever the processing is, ultimately the food is going to be preserved and therefore we have to consider very important physical parameters for the preservation of the food. Temperature is one of the important aspects for the preservation of the food and to increase the shelf life of the food. Now when I say temperature, it can be a low temperature or it can be a high temperature. A high temperature practice is done in our daily household with the use of practices like cooking, baking, frying, grilling or some other heat treatment. So in this way we are preserving the food. On the other hand, the low temperature practices are also done in the household, like when we put the things inside the refrigerator or inside the freezer and keep it for a long so that we can consume it safely for 2 or 3 weeks. Now going in for the temperature treatment, let us find the history of the high temperature preservation. Now if I go back to the history, we find that Napoleon was the first person who thought about the food preservation. It sounds very astonishing, isn't it? But he was the first person who said that if somebody could devise a safer and dependable method of food preservation, I will reward 12,000 francs to that person. And these words were announced by Napoleon in 1795. After this announcement, there were a lot of scientists working on the food preservation, but the man who really got this award is Nicolas Appert, and he got this award in 1810. Now, Nicolas Appert was experimenting with many food items and he tried to preserve it with the help of heat treatment. And he gave all his experiments in the form of a book called The Art of Preserving All Kinds of Animals and Vegetable Substances for several years. And he was able to publish this book in the year 1811. After his results were published in this book, now there were many controversies and this went for past 50 years until another Frenchman called Louis Pasteur came out with his own experiment. Louis Pasteur was the person who showed that there is a very good relationship between the microbial activity and the spoilage of the food. So with the experimentation of the Louis Pasteur and Nicolas Appert, finally we could devise many techniques that lead to the preservation of the food with the help of heat treatment or high temperature treatment. Now, whenever we treat a food with a high temperature, the microorganisms that are present inside the food, they try to resist it. And that is called the heat resistance of the microorganism, which varies according to their nature, according to the genetic makeup, or according to the chemical constituents that are found inside the microorganisms. We basically have 4 different types of microorganisms, and these are psychrophiles, mesophiles, thermophiles and hyperthermophiles. Now they vary according to their optimal temperature requirement by which they are growing and they are surviving in a particular food substrate. Now when I say psychrophiles, that means these microorganisms are the one which are able to survive at a temperature of -10 to 20 degrees Celsius. However, there is another group called mesophiles which survive at a temperature of 10 to 50 degrees Celsius. Thermophiles are able to survive at a temperature of 40 to 75 degrees Celsius. However, the hyperthermophiles are able to survive at a temperature of 65 to 110 degrees Celsius. So, we find that there is a various optimal temperature range for the growth of different type of microorganisms. Now, how to devise the heat treatment method? Because a food has got numerous kinds of microorganisms. Now, when we want to subject a food with the heat, we have to take into account the kinds of the microorganism that is present. If the kind of microorganism that is present in the food item, say it is mesophile, then we have to give a temperature which is more than 50 degrees Celsius. Because after 50 degrees Celsius, if we treat it, the mesophiles will not be surviving. However, there is another category of microbes which will survive, and that is thermophiles, because that temperature which is more than 50 degree but less than 75 degree is the optimum temperature for the growth of the thermophiles. So the heat resistance decides that how much amount of heat has to be given to a particular food item. Now there are many resistant structures and components which are present inside the microbial cells. They resist the high temperature that is given to them. And one of the most important resistant structure is sclerotia. This sclerotia is formed by the composition of the fungal mycelium. They are very hard structure and they could resist a high temperature. On the other hand, we have presence of bacterial endospores which are mainly present in the gram-positive bacteria. These bacterial endospores have got a thick spore coat, and this spore coat is made of calcium and dipicolinic acid, and due to presence of calcium and dipicolinic acid, they are resistant to high temperature. Let's try to study the factors which affect the resistance of heat or the resistance which is possessed by the microorganism against heat treatment. Now, these factors can be temperature and time relationship. For example, how much amount of temperature will be given for how long. Then we have the concentration of the cell, whether the cells are actively growing cells or they are injured cells. Then we have to consider the cultural media or the surrounding where the bacterial cell is growing. We should also take into account the various metabolic end product and also the phase of growth, whether the bacterial cells are in their lag phase, log phase or exponential phase. And not the least, we have to take into account the moisture content that is present in the surrounding, and taking into account all the factors, they exhibit a particular type or a particular amount of resistance. Now when we say resistance exhibited by the microorganism, they have got a property, a very important property, and that is called the thermal death time or T, D and T. Now thermal death time is the time necessary to kill a given number of organisms at a specified temperature. This thermal death time can be determined with the help of experiments where we subject a particular group of microbes to a specific temperature, and then we take a set of microbes and try to incubate it in a cultural media, say a nutrient agar plate. Here you can see a nutrient agar plate where at 0 minutes we find numerous bacterial cells growing. However, when the bacteria is subjected to a temperature of 100 degrees Celsius, amount of cell that is growing after 5 minutes is there. You also find the amount of cells that is growing in 10 minutes. The amount of cell is also being seen growing in 20 minutes, but we find no cell grows after 40 minutes and 60 minutes of heat treatment. This shows that the thermal death time of this type of bacterial cell is 40 minutes. Now this thermal death time can also be interpreted in form of survivor curve. That means the number of surviving cells after the heat treatment, which we find that it goes down as the time of exposure increases from 5 to 20 minutes. After thermal death time, we have another property which is exhibited by the microorganism, and that is called the decimal reduction time. The decimal reduction time is the time required to kill 90% of the bacterial population at a given temperature. Here you can see in this graph that 100% cells were there when no temperature is given. However, when a particular high temperature is given to the microbial cell, the count keeps on decreasing, and we find that the 90% cells have decreased or they are killed, and we have only surviving 10% cells, and therefore this is referred to as the decimal reduction time. If I give you an example of decimal reduction time, which is given in terms of D value, the D value at 121 degrees Celsius is taken in two bacteria. One is a thermophilic bacteria, which is Bacillus stereothermophilus. This is 4 to 5 minutes. And in the case of mesophilic bacteria, which is Bacillus coagulans, this is 0.01 to 0.07 minutes. So here we find that D value changes according to the type of bacteria, whether it's a thermophile or whether it's a mesophile. So after knowing the different aspect of temperature on the bacterial cell, let us now learn the different techniques of this high temperature preservation. The first very common technique that is known to the food industry and to all of us is pasteurization, which is named after the scientist called Louis Pasteur. Now, pasteurization can be of different type. The foremost and very important pasteurization process practiced in the industry is called HTST method. That means high temperature short time. In this, a temperature of 71.7 degrees Celsius is given for 15 to 30 seconds, depending upon the food item which is going to be preserved. Here you can see an HTST plate pasteurizer in the industry, which shows that we have presence of two different type of towers. One is called the heating tower and the other one is called the cooling tower. The heating tower is the one where you could see over here a hot water at a temperature of 71.7 to 72 degrees Celsius is supplied. And the cooling tower is the one where water at a temperature of 4 degrees Celsius is supplied. The milk, as you can see over here, is shown by the white arrow, is being flown through this tower. In the heating tower, it is kept for 15 to 30 seconds, which is called the holding time of the product. And after this, it is immediately subjected to the colder temperature of 4 degrees Celsius. So in this way, the HTST pasteurization of the milk takes place. The second type of pasteurization method seen is LTLT. In LTLT, which is low temperature long time method, we subject the food item to a temperature of 62.8 degrees Celsius for 30 minutes. This LTLT method for ice cream mix varies, which is about 71.1 degrees Celsius for 30 minutes. So depending upon the food product, the method or the temperature along with the time varies. So after pasteurization, we have production of numerous pasteurized products like milk, fruit juices, beer, and so on. The second most important heat treatment method is appetization. Now, appetization is a method which is named after the scientist called Nicholas Appert. This is basically a ultra high treatment processing or UHT processing, where we subject the food item to a high temperature. The only difference from pasteurization is in appetization, we put the food item in the container, so the food along with the container goes in for the high treatment. By this method, we could have production of fruit juices, fruits and meat. So the food item or the food content along with the container is pasteurized or given to a high temperature. Canning is another process of heat treatment where the food is put inside the metal containers and therefore referred to as the cans, and then this food or the metal cans along with the food content is subjected to a high temperature. If I consider the process of canning, we find that after the raw material is being harvested, inspected and sorted out, it goes in for the washing. And after washing, we fill the cans. After filling the cans, the brine solution is added, which is nothing but sodium chloride. After addition of the brine, we evacuate the space that is left behind by means of vacuuming. And after vacuuming, we seal the container, and this is subjected to a high temperature, which is called the heat processing method. So this is the process of canning by which the food along with the container is sterilized. Blanching is another common method of the heat treatment in order to preserve the food. In blanching, we do not cook the food, but rather a hot water is taken in a container with excess amount of salt, and the food which is going to be preserved is added in this water for few minutes, say 1 to 3 minutes. And after 3 minutes, it is immediately taken out and the water is sieved out so that no moisture content remains along with the food item. So this process is called blanching. After high temperature treatment, let us now learn about the low temperature treatment. Now, low temperature preservation takes into account two important terminologies that is known to all of us, and one is refrigeration and the second one is freezing. Refrigeration means when you store the food at a low temperature, which is about 5 to 0 degrees Celsius. That is refrigeration commonly practiced in our house. But freezing is a method where we store the food item at extremely low temperature, that is from minus 18 degrees Celsius to minus 200 degrees Celsius. There are two different types of freezing method. One is called quick freezing and the other one is called the slow freezing. What is the difference between the two? In quick freezing, we rapidly cool down the food material which is going to be preserved at a temperature of minus 18 degrees Celsius. Now this rapid cooling leads to the formation of small ice crystals which do not deteriorate the food product. However, in the case of slow cooling, which is practiced in our refrigerators, what happens is the food item is slowly subjected to the low temperature. As a result, there is formation of large ice crystals which ultimately puncture the cells and therefore deterioration of the food item takes place. Now let us learn the different techniques of the low temperature preservation. These techniques are basically performed in the food industry. The first one is the tunnel freezing method, which is done with the help of tunnel freezers. Now, tunnel freezers are long tunnel shaped apparatus kept in the food industry where we insert the food item in trays inside this freezer, which is maintained at about minus 30 to minus 50 degrees Celsius, and they are frozen, and after they are subjected to the low temperature, the food item comes out and immediately packaged. Here you can see the picture where the food item which is going to be preserved is undergoing the process of tunnel freezing. There is another freezer kept in the industry and that is called plate freezers. In the case of plate freezers, we have frozen plates which are stacked one upon the other, and between these two frozen plates we keep the packaged food material which is going to be preserved. So the food materials should be packaged before it is going on for the preservation in the case of the plate freezers. Here we can see the picture of the plate freezers which are again maintained at extreme low temperature. And the third type of freezers that is seen is called cryogenic freezers, where extremely low temperature of minus 190 degrees Celsius can be maintained. Now in this case, in the cryogenic freezers, the food item which is going to be preserved comes in direct contact with the coolant, and that coolant is either liquid nitrogen or liquid carbon dioxide. And when it comes in contact with the liquid nitrogen and liquid carbon dioxide, it immediately vaporizes. Liquid nitrogen vaporizes at minus 196 degrees Celsius, whereas the liquid carbon dioxide evaporates at minus 54 degrees Celsius. So these extreme low temperature is maintained with the help of the cryogenic freezers. Whatever the freezing technique is, whether it's a plate freezing technique, whether it's a cryogenic technique, whatever it is, it has got some problems. Now the problems of freezing are as follows. There's physical damage to the cell because there's always a formation of ice crystals inside the food product. There's change in texture and flavor because of the increased concentration of the solute inside the food. There may be the loss of vitamins, and also there is drastic change in the carbohydrate composition. So, we know that temperature is a very important aspect for the preservation, and this temperature can be a high temperature or can be a low temperature, but depending upon the type of microorganism that is present in the food, which is referred to as the bioburden, we have to subject the food at different ranges of temperature, and therefore we increase the shelf life of the food. Thank you.